In this segment, we'll talk about reviewing significant digits, which you have been exposed to in other classes as well. So if we have a number like, for example, somebody says, hey, I got $257.36. So in this case, it makes perfect sense to use the decimal format, or what we call as a fixed point format, because we have so many digits, let's suppose 3 digits here for the integer part, and 2 digits for the fractional part, which stand for the cents, and the integer part for the dollars. However, when we are talking about scientific and engineering calculations, then things can become a little bit dicey. Let's look at the thermal expansion coefficient of steel, for example. It is given as 6.47 times 6.47 micro inch per degree Fahrenheit. And if somebody said, hey, how many significant digits are here? We will say 647. And yeah, 3 significant digits. But if you were going to rewrite this number, let's suppose in the United States customary system of units, and you were going to still use the decimal format, then what's going to happen is that you would write it like this. Because 1 micro is 10 to the power minus 6, so that's why you'll have 5 of these zeros after the decimal point. Imagine if somebody said, hey, hey, can you give me the value of alpha of steel within 3 decimal digits? Within 3 decimal digits. So you would say 0, 0, 0, 0 here, and that will be what will be the value of alpha of steel for 3 decimal digits. And you very well see that we cannot report our thermal expansion of steel as 0, even when we're asking for 3 decimal digits. So that's where the problem can take place. So we've got to be very careful. So one of the things which we can do here is that we can rewrite this number as 6.47 times 10 to the power minus 6 inch per degree Fahrenheit. And what's going to happen is that you'll have 3 significant digits being shown here, with 6 being the first significant digit, 4 being the second significant digit, and 7 being the third significant digit right there. And this particular format, when you write it like this, is called the scientific format, or what we may also call this as the floating point format. The reason why it's called a floating point format is because this decimal point right here is floating from one place to another. It was here, and now it is right there. And that's why it's called the floating point format. So, having said that, that is what is of concern when we talk about significant digits, that we do understand what it is, significance is, and what it means. So, what it means is that, hey, how many digits can we know reliably in a reported number? That's the bottom line about significant digits. Yeah, but how does it pose a problem for us is important to know. Let's take another example. I live in Hillsborough County here in Florida, United States. And if somebody, my friend asked me one day, he said, hey, how many people live in Hillsborough County in Florida? And I said, I blurted out, I said, it's 1.5 million people. And you can very well see that, hey, the number is not exactly this, right? If I write it in integer format, I'll get 1 5 followed by 5 zeros, because my friend was not necessarily interested in knowing the exact number, but he wanted to just get a ballpark figure. And in this case, you can very well see that when I say 1.5 million, so I can only maybe trust or say that, hey, I trust 2 significant digits right there, but I do not trust all of them. It's quite possible that, hey, it's exactly 1.5 million, but the actual population of my county here is 1471968 as per the 2019 data available to us. So in that case now, it's not 1.5 million, but as far as we know that all of these digits are significant and are correct, so far as the knowing the population of Hillsborough County is concerned at that particular point. So in this one we'll have 7 significant digits. In this we have only 2 significant digits. But if I want to show that, hey, this number has only 2 significant digits, I'll write it as 1.5 times 10 to the power 6. And if I want to show all the digits are significant in this one, so then I'll say 1.471968 times 10 to the power 6. And that's how I would represent the two numbers to show the correct number of significant digits. Can you figure out how many significant digits are in a number? So let's suppose we have 2.789, and this will also help us to figure out the rules of significant digits. So if you look at 2.789, it has 4 significant digits, guys. So it has 4 significant digits. Why is that so? Because all the non-zero digits are considered to be significant, and it has all non-zero digits. Now let's suppose somebody says 0.0439, and in this case what we'll have is any of the zeros which are to the left of the first non-zero number are not significant. So this 0 is not significant, this 0 is not significant, but this 4, 3, and 9 are significant. So we have 3 significant digits here. So you can see the rule there about that. Now I could have a number like 4.590, and now how many significant digits does it have? It has 4 significant digits here. We have 4, 5, 9, and 0. And somebody will say, hey, why is 0 also a significant digit? Is because all the zeros which are to the right of the decimal point, which are being shown, are considered to be significant. So how about this number like 4008? 4008 has 4 significant digits because all the we have a non-zero number here and a non-zero number here, and we don't have to worry about the non-zero numbers which are in between. So which brings us to the next one right here. So that here in this case any zeros which are between non-zero numbers, they are significant. But let's suppose if we have a number like 4208.07, what about in this case? In this case we'll have 6 significant digits because all the zeros, no matter what the decimal point is, are between the two non-zero numbers here, in this case 4 and 7. So let's look at this number here, 4000.0, and in this case what we'll have is we'll have 5 significant digits. And why is the case as such? Is because all the zeros to the right of the decimal point are significant. So which brings us again to another example like 4008.0. How many digits are correct? We'll have 5 significant digits here as well because all the zeros to the right of the decimal point are considered to be significant. So having said or having talked about all these different rules here, now the only one which is left over is a number like this. So if somebody gives you 15,000, you don't know exactly how many significant digits there are. So in this case you can say there are 2 or maybe 3 or maybe 4 or maybe 5 significant digits. So when somebody asks you how many significant digits are correct in this answer, you should say 2, 3, 4, or 5, not pick and choose based on what you think is correct. But this vagueness which we have now in these number of significant digits, that can be addressed by using the scientific format, or what we call as the floating point format. So both are the same, just like fixed format is same as decimal format, scientific format is same as floating point format. So we can write like this: 1.5 times 10 to the power 3. This will have 2 significant digits, 1 and 5 here. 1.50 times 10 to the power 3, that has 3 significant digits. The number is still 15,000. And then if you have 1.5000, let's suppose, times 10 to the power 3, that all the numbers which are in that 15,000 are considered to be significant, you can write as 1.5 followed by 3 zeros, and this will have 5 significant digits. And what all of this does is that it takes away all the vagueness of representing the number like this one, where it can have 2, 3, 4, or 5 significant digits based on this number right here. But if you want to signify exactly how many significant digits one can rely on, then you'll have to rewrite it in the scientific format. So all of the rules have been covered in the examples which I gave you. If you think that there is a number which you are unsure of, put it in the comment statements and I will reply it there. And that's the end of this segment.